Class, this is the test you would have taken. I don't want to lose teaching days. I'd rather be here working, doing things, teaching, covering material every single day. So I give this to you as a take-home test. It is a gift because you can work together. What do you have to make sure you do on every question? Show your work. No work, no right.
Wait, even for multiple choice?
Even for multiple choice. Show your work as to how you came up with the answer. Now, I've said this a million times. If I give a take-home test, I fully expect you to work together. I do not expect you to work alone. You are crazy if you work alone. So you should do the test on your own. Then you should get together with some friends. Not in the hall at 8 o'clock in the morning. You should get together at a predetermined time and place. You should work the questions over together. A good place to do it would be like at Extra Help here. I know there are a number of kids who come into Extra Help every day. By all means, you can get the pretest, if you will, the rough draft of the pretest done at home. And then you can come into here at Extra Help with 3, 4, 5 of your friends, go sit at the table in the back and work on it together. I won't help you, but you are welcome to help each other and work things out and arrive at solutions. Realistically, look, in the ideal world, I think everybody should get 100 on it. But realistically, allow for sloppy mistakes, blah, blah, blah. I can't see anybody getting under an 88. Realistically, pretty much everybody will be in the 90s or 100, as long as you are responsible and focused, and then you compare answers with other people and make sure that you're all doing it the right way. Okay. When's it due again? Monday. Very good. Okay. So let's finish up what we worked on yesterday and take a look at last night's homework. First off, the first 2 questions. This should, yeah, it does say 1, 4. Okay. Yes.
Whenever we do a sketch, do you post the coordinates?
No, I did that for a point of emphasis to you guys. This coordinate's extremely important. That it passes through there because when x is 0, 4 to the 0 is 1. After that, I just did it to emphasize how you might know that that's the graph. All right? Next up, scan 2. Now, I want to talk about this one. Ready? So everybody get here. This is the last part of yesterday's lesson. Yesterday's lesson was a 2-parter, and I don't know where the time was. Oh, remember the bell went early and everything?
Yeah.
Even though the bell went early, I still should have been able to cover a little more material. I really don't know where the time went, but let's finish it up now. The first thing we learned about yesterday was the line of best fit. It's also called a linear regression, or either of those two. And what we would do is we would enter this data into L1, and where would this go? L2. And then how do I get to linear regression on my calculator?
Line reg.
What?
Line reg.
Yeah, but what do you do to get to where it says line reg? Stat calc. Scroll down till you see linear regression, AX plus B. When you do that, everybody look in here because I want you to look. Everybody look. They already did this for you. I'm going to take you right through it. They did all the work. Ready? Look at it. This is the linear regression. Now, they did the opposite order one, the B and AX, instead of AX plus B. It doesn't make a difference. If you chose AX plus B, this would be in front, and this one would be in the end. I like the AX plus B. It's not a big deal one way or another. All right, so this is your line of best fit, the equation of the linear regression, et cetera, et cetera. Now, if I drew the line, it would go through more or less the middle of the points. Now, are any of the points actually on the line?
No.
Are some of the points pretty close and some of the points pretty far? Yeah. To understand or measure the distance that a point is from the line, we use a concept called a residual. What do we call it? Residual. Residual means left over. For instance, let's say that I'm doing a project in my house and I'm framing out or putting molding around the window. When you go to Home Depot or Lowe's or wherever you go to go buy the molding, you don't get exactly the length you need. you have to buy extra. And then you cut all the molding pieces and you put them all around the window, you get it nicey nice, you're very satisfied, and there's some left over at the end. That leftover would be called residual in the English language. Likewise, in the mathematical language, residual has this idea of leftover to it. Are you with me here? Because I don't want you to blow this. It's an easy concept if you're focusing and following. If you're out in La La Land, you're gonna miss it. Residual is this distance here, this distance here. And here's how you find residuals. Well, here's the best example. I need to put my glasses on so I can read this. Ready? For x equals 25.33, you put it into the equation and you come up with 39.9, okay? All you do is plug the x in the equation and compute what it comes out to. It comes out to 39.99. Now what that means on the graph is that at 25.33, you're at 39.99 on the graph. But the point is not on that. So you need to measure the difference. So what they do here is they tell you that to calculate the residual, you do the residual minus the actual. So the residual, the actual value was 39.9, but if you look on the graph, the value is 43. Or you can look right here, ready? See how at 25.33 it says the value is 43? Does everybody see that?
Yeah.
But we just calculated if we plugged in 25.33, if I plug it into this formula that I had just gotten before, where is it? It is, here it is. If I plug it into this formula, I don't get 43. I get 39.9. So I do 43 minus 39.9, and this gives me this. This is your residual, okay? So all the residual is, it says it right here, residual equals actual minus predicted value. So the actual value was 43. According to the formula, it should have been 39.9. So when I subtract, I get 3.1, and there's my residual. Here's another example, 27.79. When I plug in a 27.79 into the table, what do I actually get?
30.
I actually get 30. Now, if I come into the formula and plug it all in, I get 36.1. When I subtract, I get negative 4.1. What's that?
Is it predicted minus actual or actual minus predicted?
It is actual minus predicted. Actual minus predicted. Okay? So that will give you the measurement of the residual every time. So what is the residual, everybody? It's the difference between the predicted value and the actual value. So you do the actual value minus the predicted value, and it tells you the residual. The way they will ask it on the Regents exam, they will ask it in two ways. The first way that they will ask it is if they will ask you to calculate the residuals. The second way is they'll ask you, what do the residuals tell you about the line of best fit? And if, when you graph the residuals, it forms a pattern, then it's a poor line of best fit, okay? If it doesn't form a pattern, it won't. Now, the last thing I'll tell you, going into your take-home test, I tutor the Algebra 2 trig class at the high school. And there are some things in that this year that if I did them when I was in college back in 1983, 4, 5, I don't remember. And I've never taught them as part of the traditional Algebra 2 trig class. And every time that I get to the point where I look at their notes and I don't understand it, I go on Google and I type in, like one of the things that I've been doing lately is this stuff called z-factors. So I type in z-factor. And a little page comes up, I read the page, and then I know how to do it. So if you do, there's one question on your take-home test about residuals. If, God forbid, you have a struggle with residuals, you go to Google and you type in residuals, and they'll have YouTube lessons, they'll have many different things on there. You can come to me at Extra Help and ask me about other residual questions, and I will be happy to help you. But I won't do the one that's on the pretest. And you will get some on tonight's homework, and you'll get some on tomorrow's homework, so we will review them more. But I feel as if the only question on that take-home test that I'm not very satisfied you're fully capable of getting because we pounded it to death, is the residual question. So you can ask extra help about other residual questions. We just went through it right here. And you can also do it by Googling. Those are all good references to get to more explanations and deeper explanations of residuals if you feel frustrated by the one question. Yes?
Can I do my subject?
Sure. Okay. Let's go to the next page on the homework. Everybody's got to tilt your head to the side. There we go. Somebody asked me where I got these questions from. The first year that they were going to make the Regents exam, nobody knew what it would look like, and there was this company in Texas who made up these sample exams. So I bought the sample exams and came up with a bunch of questions. Number 1 is 2, number 2 is 1, 3 is 1, 4 is 3, 5 is 2, 6 is 4, and the last one there, number 7, is also 4.
Why are they sideways?
Because I wanted to fit them on the page. I didn't want to waste too many pages. Yes?
I don't get how you got number 1 for number 2.
How I got number 1 for number
Because
2.
if it says, because if 4 to the x power, it's never going to touch the x. It's never going to be 0.
I need to look at the question, and I'm going to turn my paper the right way. All right. All right, so you said number 2?
Yeah,
Yeah, didn't I put choice 2?
you put 1.
Oh, it should be choice 2. I'm sorry. I don't know why I put 1. I knew darn well it was choice 2. I did a, who's the one in here who always does something stupid on their tests? Spencer's pretty good at it. All right, Janelle also every now and
I
then.
was not
Oh,
ready.
okay.
What about me?
Okay, for number 1,
Yes.
how did it get 2?
Well, it's interesting. If you notice, when I did it, I originally circled a number 4 at 2 different points where it was level. But then I looked on the side. It wasn't distance, it was speed. So I have to go to where the speed was 0. Did you get 4 also? Thinking, yeah, that's what I thought. I thought it was distance. And thank God I looked on the left-hand column and saw that it meant speed and not distance. Yes?
Can you explain number 6?
Number 6. Which correlation coefficients? Yes, listen, the correlation coefficient is how close the dots are to the line. A perfect correlation coefficient, the dots are the line. So a 1.0 or a negative 1.0 is a perfect correlation coefficient. The only difference is negatives go down, positives go up. So negative 8.4 is a better coalition than any of those positives because it's closer to negative 1. Okay? Any other questions? All right. There are these 3 after it. I apologize for not being able to graph the last one. I should say not being able to factor the last one. All right. If you can factor all 3 of these, assuming I give you a factorable one, if you can do all 3 of these types, I would say you're really close. The only other thing you have to be able to do is that one where it's the difference of 2 perfect squares twice. If you can do all of those, you can do any factoring I could possibly throw at you, which means you're really ready for the Regents, and you'll do very well in future math courses because factoring is extremely important up there. Oh, great. All right, and here is the 4th page. All right, any questions? Good. All right, so let's get to today's lesson, which is just a quick little review of step functions. This is very much like yesterday. Is there anybody who had a hard time with this? Did you plug in, it says the interval from what to what?
There wasn't an answer. I
From
couldn't find an answer.
from 0 to 3 would be 0, 0, and 9 minus 12 is negative 3. So this is negative 1. This is 13 over 3.
Yeah, I didn't agree with any of these.
It should be F first, then one of the other ones. So
It's F first, H.
it's
second.
FHG. Okay, as long as you knew how to do it. Don't worry about the choices. All right, so let's talk about step functions. And I just want to remind you of how to do these because I feel like I wasn't rock solid on getting this across to you. And this, I think, will serve to just cement the idea in your mind. The thing about projection mode on in. Come on. Good. All right, so the thing about this is there's two different functions here. And which function you use depends on your input. Remember, x means input. If the input you give is less than or equal to 2, use the top function, 2x squared, which, reminding you, means square it, then double it, not the other way around. And this one means do 3 times the input minus 4. So which formula do I use for negative 3? Jano?
The first one?
The first one, because negative 3 is clearly less than or equal to 2. Negative 3 squared is 9, times 2 is 18. Which formula do I use for the bottom one? Everybody?
3x
Second
minus
one.
4.
Right, because 3 is greater than 2. So 3 times 3 is 9, minus 4 is 5. Okay, any questions? All right. Now, here's a good example. Ready? At a parking garage, it's $7 for the first hour and $2 for each part of a half hour after that. So it's $7 for the first hour. So for the first 15 minutes, how much does it cost? $7. How much for 55 minutes? $7. It's still $7. Now we get to 70 minutes. That's going to be the first hour, which is $7, and $2 for each additional half hour. So this is 9. Now, what would 90 minutes be?
9.
9 also. Now, 110 minutes becomes, what does 110 minutes become? 11. And what's 135 minutes become? That would be 2 full hours and another part. So 7, 9, 11, 13. Okay? 7, 7, 9, 9, 11, and 13. And then you just actually graph it. If you guys would remind me tomorrow when we come in the room, I'll just do the graph for this. I want to show you how it looks like a step function so you know what it is. All right? And then that'll serve as our review of step functions. But please remind me tomorrow to actually make that graph. I think it was easy enough to calculate the values in the table, but I might forget if you don't remind me.